Hello everyone, welcome to our presentation. We are team 1100 from PMAC, Project in Mathematics and Application. Our team consists of me, Nguyễn Phat.
And my name is Nguyễn Phat.
And I'm Phung Nguyen. Our coach is Nguyen.
So for this SCUDEM challenge, we choose to analyze and develop a mathematical model for problem B titled an AI Ouroboros. Let me walk you through the structure of this presentation, which covers 6 sections. Firstly, the introduction, secondly, the assumption, thirdly, the model, fourthly, the results analysis, fifthly, the limitation and improvement, and finally, the conclusion of this problem. First, the introduction. So AI is no longer just a tool today, it's becoming the main storyteller in this today's digital world. But this is raised a key concern, are we spreading knowledge or amplifying misinformation? And to explore this, our model simulates the spreading and interaction of 6 dataset components, from human-generated to various levels of AI influence and misinformation. So this challenge requires to answer this question here. And first of all, what is the exact definition of model collapse? So after finding many papers and resources, however, we cannot find any agreement about this topic across them. This table shows how model collapse is defined in each paper. Thus, based on the most common point of the agreement, we have come up with definition 1, model collapse. So we define one model that collapses when the relationship between model performance and the training data size deviates from the expected scaling behavior observed with real data. And our goal was to explore the influence of multi-AI models on model collapse by paying special attention to the change of dataset component. And furthermore, we want to study the long-term behavior or pattern of the dataset component and to get some insight to mitigate or at least slowing down the model collapse. And then move to the second session, some key assumptions of our model. First of all, we will choose 5 AI models on behalf of multi-AI because in reality, the 5 most well-known AI account for over 98% of the market share. This allows our model to partially reflect the overall accuracy of AI system. And for T generation, we also define some variables here too. First is IT is an amount of human-generated data on internet at T generation. Similarly to BT is the minimally, substantially, dominantly, and poorly AI-generated data. FT is an amount of misinformation data on internet at T generation. IT is the information gained from the dataset at T generation. A1 to A5 is the accuracy of 5 model at T generation. L1 to L5 is the learning accuracy of 5 model. K1 to K5 is the amount of output data generated by 5 model on each generation. K0 is the amount of human generated data on each added to each generation. And WB to WE is the component percentage of output data generated by 5 model on each generation. And as you can see, here is measured in bytes. So furthermore, we also define generation 0 as the total amount of data already existing on internet before the appearance of AI, which simplified to the human-generated data estimated at about 2 times 10 to the 23, measured in bytes. These are some key assumptions of our model. Firstly, our model is divided into 6 distinct components, each representing a different level of AI influence in content on the internet, which are human-generated data, 0% of AI, minimally, substantially, dominantly, poorly AI-generated data, and here is the percentage of AI influence. And also added to misinformation, the misleading or false data. And for each AI generation, some parameter will also remain constant too. First, the amount of data generated by both human and AI is fixed. And secondly, the distribution of human influence on AI output is fixed. And information decay rate and misinformation decay removal rate are fixed. And so turning to the parameters, first we assume information gain of human for AI and misinformation is 1, 0.5, and -1 respectively. With that, information gain from misinformation is equal to -1, and this will confuse the AI and decrease the AI accuracy, and then calculate other values based on the percentage, the average influence of AI in each component. In the second column, based on the data about how many pages are created or assisted with AI, we can assign a percentage for each component. And also based on this pie chart, we can assign a percentage for each component. We can calculate the percentage of AI output for each component, which is also the third column. And after doing some research, we find out that AI generated data decays 2 times faster than human data in general. And based on that, the percentage of AI influence in each component, we assign this value.
Let's move to the model. Let's take a closer look into the equation. We will take minimal AI influence data as an example. So this is the percentage of AI output belong to that data, and this is the cumulative contribution of AI model weighted by accuracy, and this is the decrease of that data over time. We will do the same process for A, C, D, and E. Turning to mid information, this represents for the total mid information generated from 5 model each generation. And this represents for the total regression of information. And this is the remove misinformation. We will introduce information gain and the accuracy of AI. Information gain reflects the quality of dataset beyond its component. It's always less or equal to 1. When it's equal to 1 means the dataset include only human-generated data. Accuracy of AI include information gain represent for the quality of dataset, and learning accuracy represent for the efficiency of learning of that model. Here's how data flow. We would like to analyze the result we got from model. Before showing the result, we will assign this value to learning accuracy. We will compare the top 5 and the best one. First is the influence of human in this model. This is the case when human output data take the majority, and as you can see, it prevents the degradation of AI. So human play an important role in this model. Next is the role of misinformation detection. Higher removal rate means it prevents misinformation spreading better. Finally, we would like to address the advantage of multi-AI. We will take the top 5 and the best one in this red dataset. Here the result. In the first half, there aren't any big difference, but later, multi-AI performs slightly better. The reason behind it is because the data output each generation is divided into 5 AI, and it helps prevent the uncertainty of AI. That is the second advantage of multi-AI, which is more interesting. An AI performs best in this dataset, but that doesn't mean it will perform well in other datasets. We will take the top 5 and the best one in this blue dataset when being asked to do the red dataset. Here the result. And as you can see, multi-AI perform completely better than single AI. As we mentioned before, there aren't any metric that help us know which AI is the best in general. Therefore, if you choose the AI perform best in the blue dataset, who knows how it will perform in the red dataset. To sum up, single AI only give a single viewpoint, while multi-AI cover more viewpoints. This is why it is better to choose multi-AI.
So we've seen the model and the simulation results. We are now covering the model's limitations and, importantly, our final conclusion. These are the limitations. Information gain is flawed. The model ignores AI specializations. Misinformation was oversimplified. The model ignores real-world growth, and we do not have enough data yet to build perfect parameters. Okay, so how could we make this model better? First, we categorize data by topic. Second, our model assumes a fixed amount, but we know that the internet is always growing. And finally, we prioritize new data. Next, we move to the last part, conclusion. Well, after all this analysis, we have the answers for these questions. The first answer. AI-generated content and misinformation quickly overwhelm the human data, causing the overall quality to drop rapidly. The AI loads from this polluted dataset, so its own accuracy drops sharply, leading to lower quality new content. The long-term part is model collapse. The system stabilizes at a low quality level, and human data becomes a tiny minority. So it declines rapidly. The graphs show a steep drop in the first 100 to 150 generations before it bottoms out. If you look at the graphs on the slide 27 to 29, you will see the multi-AI scenarios on the left always stabilize at a higher quality than the single AI scenario on the right. This is clear proof that the wisdom of the crowd approach works. So yes, the model shows it reduced the severity of the collapse. So after all that analysis, here are the key ways our model suggests we can reduce model collapse. So can we just use pure human data forever? The answer is no. We are literally running out. This means the AI Ouroboros isn't just a risk. We must use synthetic data. And here is the source we used. Thank you for your time.